Hello everybody, and welcome to another Science with Crayfishcraig. And as you see, here's me, my little me. Hi me. So since everybody's been asking and has been a bit confused about the about pH in general in chem, and since extra credit was due, Mrs. Palmer. Hi, Mrs. Palmer, if you're watching this. Decided to let me do this for my extra credit, which works out great for everybody. Great idea. So, what exactly is pH? Well, pH is the measure of how concentrated water is with hydrogen ions, the positive ones, versus the concentration of negatively charged OH particles. And you may know 2 H's and 1 O make water. So water itself is made up of an acid and a base, or at least parts of one. An acid is something that has is a molecule that has a higher concentration of H positive ions. These ions tend to get mixed in with other particles such as chlorine. Chlorine plus hydrogen equals hydrochloric acid. Now, hydrochloric acid is that way because of how acids work. Their very structure is a differently charged particle to which it's normally. And it's not only how strong the acid is, but how diluted or concentrated it is. You can get a very high acid burn from a very normal pH. Normal pHs, such as ones that we tend to deal with more on a daily basis, range in the pretty much the more normal numbers. Pretty much and as it's called in most other scientific circles, the Goldilocks zone. This is a zone that holds the best chance for life. Right smack in the middle. But it's not just the exact middle. You need to have some variation. And in terms of space, we are in the Goldilocks zone, meaning we're not so far away from the sun as we get frozen, and not too close to the sun as we get fried. So it's pretty much that. You don't want to get we're pretty much staying in the middle from getting burned or getting burned. So, but it's also concentration. You can have a very weak acid or a very weak base and have it super concentrated to the point in which it can burn you in an instant. So the way this works is it's not the hydrochloric acid that's making real acid. Acid is technically H3O+, meaning when hydrochloric acid comes in contact with water, it technically actually becomes hydrochloric acid because it separates from the hydrogen ions separate from the chlorine because, well, chemistry. The hydrogen ions from the hydrochloric acid leave that chlorine molecule behind and join with water, making acid, H3O+. That is what happens when it's acid. Bases are created when a more basic solution, I should say, is created when a base, such as ammonia, it reacts with water. Instead of doing normal stuff and saying ammonia and water, it instead turns it into a ammonium ion, meaning that it has one extra hydrogen, meaning it took away a hydrogen from water, and a hydrogen from water, making it OH negative, and add it to ammonia, making it ammonium. This makes the solution more basic, and the more concentration, and the more basic the base. That just sounds odd. It is a measure of the concentration of hydrogen ions, or hydronium ions, in the water. And hydronium is the term for H3O positive. Now, well, the maths. I thought I put in basic terms there, and I went for the more basic look here. Really, you had to, really, I'm editing this myself. You had to be that mean. Okay, now you're just being real mean. Now, back to the maths. Hydronium concentration equals K of W, or K of water, divided by hydroxide ion concentration. Hydroxide is a strong base. Hydronium, a strong acid, is technically acid. So that's how that works. You have to. This is how you find pH with just the concentration of one of them, or you could actually, if you have, as long as you have two of these measurements, you can find the third one. Regardless. Now, to find a buffer, find the concentration a different way. As with pretty much any science, there is a convoluted way to find anything, or a non-convoluted way. You can go through many different paths, but these are kind of some of the more base. I'm not gonna make that joke again. More basic equations. Buffers are what you would call pretty much. They're like the scales of justice almost. They keep anything from tipping one side to the other. One power from becoming greater than another. Buffers are an acid and its conjugate base pair. A conjugate base pair is essentially an acid. Leave out one hydronium ion. No, wait. Leave out one hydrogen ion. So, for example, hydrochloric acid, which is HCl, its conjugate base would be Cl negative. They keep everything from going either one way or another. Water is kind of tricky because since it has both the makings of an acid and a base, it will, in the presence of a base, it will act like an acid, and in the presence of an acid, it will act like a base, thus changing the pH. Buffers essentially do the same thing. They keep a pH in a specific range. Our own bodies use this to keep our blood at a certain pH level, and our stomach acid at a certain pH level. Our bodies pretty much regulate all this using buffers and such to keep it from becoming either too basic or too acidic. Because if it's not at the right pH range, it's not going to function correctly, and if it doesn't function correctly, bad things happen. And if bad things happen in your body, it pretty much domino effects and you die. eventually, unless your body can correct that problem, or you can help your body correct that problem. Also, this is why the idea of drinking like water as at a certain pH level is kind of bold, because your bodies have these buffers, and it's what you use this either more acidic or more basic water for, that really depends on it, because certain bacteria like really basic solutions, some bacteria really like really acidic solutions. It's all what they're designed for. Now, before this becomes about health, let's continue with science. So, like I was saying, pH is kind of very important to everything. pH levels and, say, streams. Yes, I know you're all going to hate me for again connecting it to water somehow, but pH is essentially water. So trout have a very specific pH range. And that pH range isn't necessarily the same as another fish, say a bass. That they also have a different temperature range, but let's leave that aside. That is why you don't see many trout swimming along with bass, because they're designed to swim in different environments than each other. This is also why the rusty crayfish, an invasive species. Yeah, here's a picture of a little guy right there. Are such amazing at infiltrating our watershed right now, because they're actually not too. They're actually not that. They're literally just from the other side of the state, so it's not. So it's not like an Asian carp in which they're from the other side of the globe. So they could have gotten here naturally, but before I make this all about rusty crayfish, they have such a large range for pH levels that they can survive. That is why they seem to do so well. They have a much larger range that they can adapt to easily. And since they can adapt more easily, it can allow them to, thrive in a more diverse range of areas. Unlike our bodies, in which separate systems have to have very close pHs. If they vary too much, will kill us, or at least cause permanent damage. So it's used to make sure everything's healthy in our body, in our ecosystem. Even if a fruit is healthy or not, or if it's ripe or not, or if a food's good for you or not. Heck, it's even used for preservation reasons. And like I've said before, everything in life is a balance between good and evil, acidic or basic, chocolate, vanilla, light and dark, too much, not enough, etc., etc. It's a balance between everything, and we need to make sure. And so everything's a balance. Now, if you have any questions about topics I didn't cover, I can always make another video for an area that you are confused about. Pop a comment or a comment in the below, or you could always email me, or seeing how this is probably going to be seen by mostly people in my class, just ask me in class, or after class, or before class. It works. I will also please like, comment, and subscribe. And if there's anything that you would like to see other than science or Minecraft or the few Skyrim videos I have, if you would like me to continue to stop them, to do another series, just tell me and I'll do it. And I'll probably most likely do it. As long as it's not overly embarrassing. Please like, comment, and subscribe, and I hope you have a wonderful day. Bye!